Since the early 1960s, improvements in aquaculture technology have increased productivity. In early days, pond production yielded 2,000 to 5,000 pounds per acre, whereas enhanced photosynthetic systems, utilizing increased aeration and water mixing, expanded production to 10,000 to 18,000 pounds per acre. The last few years have seen the development of bacterial treatment systems allowing super-intensive recirculating aquaculture systems, yielding as much as 50,000 pounds of fish or shellfish per acre. U.S. aquaculture started as pond fish production in warm areas like Mississippi and Alabama. Use of intensive aeration allowed catfish production to expand from 2,000 to 10,000 pounds per acre. And in Asian tropical zones, intensive aeration and water discharge enabled shrimp production to expand from 1,000 to 10,000 pounds per acre. Over a period of 10 years at Clemson University, the patented partitioned aquaculture system was developed. This uses paddle wheels to move water to enhance algal production, resulting in expansion of catfish production to yields of 15,000 to 18,000 pounds per acre. At the Warmwater Aquaculture Center in Stoneville, Mississippi, researchers developed a lower-cost version of the partitioned aquaculture system named the split pond system, which uses earthen fish culture basins within existing ponds rather than concrete raceways. These systems demonstrated 12 to 16,000 pounds per acre at about half the capital cost. In temperate zones, raising fish within in-pond raceways can enhance production, like this multiple in-pond raceway used for catfish production at Auburn University. This small-scale in-pond raceway in Missouri has the advantage of utilizing an existing watershed pond to support fish production. Intensive recirculating aquaculture systems provide the advantage of limited or zero water discharge to the environment. There are two primary types of limited or zero discharge RAS systems. The outdoor ambient temperature RAS is more cost-effective for warm climates, or alternatively, year-round indoor controlled temperature RAS techniques used in Missouri and in the Midwest for marine shrimp production. Recirculating aquaculture systems must supply all of the requirements to support fish growth, including containment of the fish within tanks, mechanical filters to remove particulate solids, biofilters to remove ammonia and nitrite, and degassing systems to remove excess CO2, and then finally, replacement of oxygen and ozone, and/or ultraviolet disinfection to maintain water clarity and reduce bacterial contamination of fish. In warm climates, it's possible to operate large-scale open-air RAS systems. This system is used to produce hybrid striped bass outdoors at the Kent SeaTech Corporation in California. Clean water RAS systems use biofilters, supporting bacteria grown on plastic media, providing oxidation and conversion of potentially toxic ammonia to harmless nitrate. Biofilters can be constructed using locally available materials as reported in a recent publication, or they can be purchased for installation to treat ammonia in recirculating aquaculture systems. This biofilter is provided by a Louisiana company called Aquaculture Systems Technology. This standalone bead filter system is used at Auburn University for fish culture, and this constructed foam fractionation unit is used for marine shrimp production at Texas A&M University. Foam fractionation is different from bead biofiltration. Bead filters mainly grow bacteria to remove ammonia, while also removing particulate solids. However, foam fractionation is primarily used to remove soluble organic materials, particularly proteins that accumulate in water, increasing oxygen demand, leading to a deterioration in water quality. In addition to bead filters, a rotating drum filter can also be used to remove particulate solids from aquaculture water. Another technique increasingly utilized in aquaculture is super-intensive Bio-floc aquaculture. Bio-floc uses high levels of microbial solids in excess of 300 milligrams per liter suspended within the same water used to grow the culture organism. In this example, a super-intensive Bio-floc system is being used at the University of Missouri for zero-discharge shrimp production. The settling cones show the high suspended solids levels used for ammonia treatment. While these systems work well, they are limited to aquatic animals that can tolerate high suspended solid levels in the water. For aquaculture production in the cooler climate of Missouri and the Midwest, it's suggested that indoor, climate-controlled shrimp and fish culture be used to allow maximum production and profit. Bio-floc RAS is best suited for warm water, high solids tolerance species such as tilapia, marine shrimp, bass, catfish, and carp. On the other hand, biofilter RAS is best suited for cool or cold clean water species such as trout, salmon, yellow perch, and bass, whereas an intermediate temperature animal could be grown in either a biofloc or a biofilter system. One of the major advantages of a recirculating aquaculture system is the 100-fold reduction in water usage, providing reduced or eliminated environmental impact. This presentation from the Food and Agriculture Organization publication shows flow-through aquaculture requiring 30 cubic meters of water per kilogram of fish, in contrast to 0.3 cubic meters needed in RAS super-intensive aquaculture systems. A major disadvantage of RAS is the increased cost of production. Pond production costs range between $1 to $2 a pound. However, RAS recirculating aquaculture costs are more than double at $4 to $8 a pound. This means that to ensure profitability, RAS production requires the farmer to sell directly to restaurants or consumers. Contact the University of Missouri Aquaculture and Fisheries Extension Program to learn more about the technological advancements in aquaculture and the opportunities that sustainable seafood production presents to Missouri farmers.